And we'll just pull some IXL examples so I make sure I cover everything that's in IXL. So we're doing synthetic division. Synthetic division is an alternative to long division. And you can use it when you're dividing by what we call a linear factor. Now, a linear factor would be something like 2x plus 4. That's an example of a linear factor. Do you see y equals mx plus b in that thing? That's linear, right? Okay. Maybe something like 9x plus 3. That's linear too. Use it when you see linear factors. Uh, even when you did that long division stuff the other day, there was a lot of stuff in there that you were dividing linear factors, or was. You can't use it for anything else. So you can't use it when dividing by a nonlinear. An example of a nonlinear would be when you're dividing by something like x squared plus 3, because x squared plus 3 is linear. That's quadratic. But if you see a linear factor, you're allowed to do synthetic division. I can't believe y'all didn't get the pickup line. Hey, you're all math nerds. You don't date. Lindsay, you should have shared it. Can I do what? Oh, you're welcome. Hopefully you remember this from Algebra 2. Make an example here. Actually, I'll just go ahead and pull the first example I see off IXL. I'll do that. Here's our example. Find x squared, use synthetic division to find x squared minus 5x plus 6 divided by x minus 3. And they've got how they want their answer written. Put that down in your notes. Write your answer in the form q of x, q standing for quotient, okay, plus r over d of x. R or q of x is a polynomial and d of x is a linear polynomial. Simplify any fractions. So they're going to want us to simplify this remainder. Let me full screen that so you can see it better. Now, synthetic division it assumes that the divisor, what you're dividing by, is a factor. It just goes ahead and makes that assumption. What you're dividing by is a factor. So we're going to assume x minus 3 is a factor. If x minus 3 is a factor, what is x? 3. If x minus 3 is a factor, x equals 3. Because 3 minus 3 is 0. You're a factor if your remainder is 0. Now, do you guys remember what we drew? Nobody? You're not 10s. You're not even 5s. Come on, you drew an upside down house. What'd you throw outside of that upside down house? 3. And you loaded the second floor with the coefficients. What are the coefficients? 1 in front of x squared. -5. And the last one's 6. I always taught this DMA. Drop, multiply, and what? Add. So drop, multiply, and add. Again, I even said last year I wish it was DAM so I could cuss every day at you, but no, it's not. DMA, drop, multiply, and add. Of course, you can only do the drop once. What are you going to drop? 1. 1 drops. And then you multiply. 3 times 1 is 3. And then you add. -2. And then you multiply. -6. And then you add. Ah, this is a nice example. This is my remainder. If you have a remainder of 0, what does that mean? It was actually a factor. It was a factor. You know, 2 goes into 4 2 times with a remainder of what? 0. So a 0, this is telling us it's actually a factor. Now, I don't know if you remember anything about the positions or not, but this is your remainder. Preceding a remainder is what? A constant. Preceding a constant is the x value. If there was anything here, what would it represent? X squared. And that pattern continues forever. Now, this space right here, everything prior to the remainder, that represents the quotient. The stuff that's left over. So the quotient is x minus 2. That's all it is. And that actually happens to be the answer to this one, because there is no remainder. X minus 2 is the answer to this one. Now, if you go back and look at the original problem, because this one was meant to be easy, and you did the factoring lesson, how does x squared minus 5x plus 6 factor? X minus 2, x minus 3. Okay, that's how it factored in the first place, and that's what we got as a result. So there's no need to add anything. If we just go to IXL and we type in x minus 2, it's done. I don't think it's going to want us to say plus 0. I'd be very surprised if it did. Wonderful. How about that? Now, No, it doesn't. I'm going to level up. So now they've given it to us as a fraction. Don't sit here and like throw away x's. You can't do that stuff. You know that. But they've given it to us as a fraction. Still the same deal. Write your answer in the form q of x plus r over dx. And we haven't gotten to the point where we need placeholders yet, but maybe this one does not come out to have a remainder of 0. I don't know. I haven't done it. I guess I could plug a 4 into it real quick and figure out. In fact, I'll do that before I start. Oh, it has. You're right. It doesn't have a remainder. Let's do a different one here. This one should have a remainder. This one will do. Oops. So our next example is x squared minus 3x plus 35. And I'll just write it as a fraction. We're dividing it by x minus 5. Is x minus 5 a linear divisor? Are we allowed to use synthetic division? That's the deal. You're dividing by something linear, you can use synthetic division. All right, so again, we assume x minus 5 is a factor. What do we divide by then? Or what is x? 5. So why don't you take a minute and see if you can set it up. See if you can set it up. If you can do it, do it. That's fine. But take a minute and see if you can do the setup properly. If you want to get started on it, get started on it. Every one of you did at least 30 of these last year and gotten a whole lot more. Remember, write your answer out. Don't just stop with synthetic division. You've got to type this thing in a certain way. So try to write the quotient plus the remainder. Most of you got it. At least you're on your way. That's how lots of you doing it right. You throw that 5 out front. Your coefficients being 1, -3, and 35. And you dropped. And you multiplied. A couple of you made a little mistake here. -3 and 5 is 2. 2 5s is 10. And you add, and there's at least 2 people that subtracted here, but you add. There's your 45. So what's the quotient? X plus 2 is the quotient. 1x plus 2. Then you got your remainder. It's supposed to be given as the remainder sitting over the divisor. So plus 45 sitting pretty over what? X minus 5. That's it. Really not that bad. There's Kelly. Nope. And let's see if I'm right. X plus 2 plus 45 sitting over X minus 5. Submit. Well done. Good job, kids. You want to level up? Or do you need to see another easy one, or do you want to level up? Do you care? I'm going to level up. You have to have 55 to get this level. That's what it says down here. If you look at the score, once you hit 55, you go to this. Now, this one's a little bit different. I'm going to write it down. You can write it down as well. You can see that. Here, Kelly, you can have the first page of notes. Anybody notice anything special about this one? Why I said it was a little bit different? Why it might be in the next level? Why might it be in the next level, Lauren? You gotta have a placeholder. If you look at this thing, it's missing X, isn't it? So we gotta have a placeholder. So we're going to use a placeholder of 0x. Now, at this point in time, we all know what we're going to put outside the house. What are we putting outside the house? 1, positive 1 at that. What's in the second floor? Tree. What's the next number? -6. How about after that guy? 0. Got to have that placeholder. Followed by -38. Now, this one's pretty simple, too. The multiplier is a 1. You know. Put some other numbers out there, it gets kind of rough. Now, so what am I going to do after I do the drop? Annika, what am I going to do after the drop? Multiply. 1 times 3 is 30. Lindsay, what do I do from here? Add. What do you get? -3. Jaden, what do I do here? Multiply. What do you get when you multiply? These two numbers. -3. Then you add. And then you do what one more time? Multiply. I guess I need to have y'all do another one of these. Then you add. Cool, this one wasn't a factor. I had a remainder. And I want to type this one in on IXL to make sure. I know if you read the instructions, doesn't it say plus the remainder? But I don't think it's going to be the case here because the remainder is negative. I think we're going to do minus, okay? All right, what's our quotient? No, this is the remainder. Constant x squared. Remember, you kind of got to work right to left on these when you label things. So what's our quotient? Minus 3x minus 3, right? Did y'all all ride the short bus this morning? Kelly says yes. All right. I'm going to say minus because that's a negative. Okay. I'm not going to say plus. I'm going to say minus. That's a negative. 41 sitting over x minus 1. I'm curious to see what IXL does, if it wants us to say plus or not. If I miss it, I miss it. Okay. But at least you'll know. That's the only problem with when somebody writes a program. You don't know how they want the answer. Oh, I wrote the problem down wrong, didn't I? Well, shoot. So don't really change your notes here, okay? I'm just gonna fix it, but don't change your notes. The example we did is right, isn't it? Yeah, it is. I just wrote the problem down wrong. Is that negative 27? Negative 29. No, 47. Still negative. That's not how this one works. Yeah, it doesn't. When it's you don't when you sample it negative, you do minus instead. That's kind of why I want to do that one. Well, I think I'm going to have y'all do one. I think I actually want y'all to do this one, and I'll write it down so maybe you can see it better. I don't know. Make sure I write it down correctly. And after that, we'll level up. That one does need a placeholder. It does. There's something missing. What do you want? I'm gonna look at that one real quick. What's missing on this one is not an x. What's missing is a constant, right? So that's a little bit different. It is missing a constant. And you gotta talk about that constant. So the second story is a 7, a negative 20, a 12, and then a 0. You're missing this plus 0, or this plus a constant, whatever's there. That's where the placeholder actually belongs. I didn't see anybody mess up with the outside of the house. I don't think I saw anybody mess up with multiplication. So I dropped the 7, multiplied, got 14, added, got negative 6, multiply, get a negative 12, add, I get a 0. And some of y'all stopped there because you didn't realize about the placeholder. Twice a 0 is 0 still, and here we go. And the big mistake was we just saw this and wrote 7x minus 6. This is your last position. That's the remainder, okay? The guy before that represents a constant, before that an x, and before that an x squared. This is your answer, 7x squared minus 6x. And that has to work because x minus 2 times 7x squared minus 6x has to yield this. You have to be able to get back to this. So you can't just say 7x minus 6. Anybody got any questions on that one? All right, I'm going to level up instead of letting y'all try. Because what are we at right now as far as the SMART score goes? We're only at a 60. What's y'all's goal? 90. All right, so the next level happens at 83. So if you can do that, it takes you from 60 to 83. So you got to get through this one to get to your 90. Anything looks special about this one? Other than it's an x to the 4th? I'm going to make sure it is not a factor. There's a way to do that pretty quick. That's actually a factor one. I want something with a remainder. Is that the same question? I hate it when it does that. You know what? That's fine. I'll just break the problem. We just won't type it in on Excel. Sometimes iExcel will present things as fractions, so I'm actually just coming up with a new problem. I did not write that problem down. I made a different problem, something that wouldn't work. That's that one right there. You know what? I'm going to make it a little hard, a little tougher. Do that. It's not actually that much tougher. It's really not. There are actually, looking at this problem, there's two ways of doing this. And we'll do each other way. There's two solid ways of doing this. If we just look at the problem and just focus on this piece down here and think about x, you know, we think 2x plus 4 is 0. What's that make our x value? 2, right? Not just 2, negative 2. So we could do synthetic division the way we normally do it. Throw a negative 2 out front. It looks to me like there's a jump. Does anybody see a jump from x to the 4th x squared? So I got to introduce the placeholder. Negative 20, 28, negative 8. This would be example 1 of doing it. And then you could just kind of go through your steps here. There is a way to make your work easier. Look at every single piece of that fraction and tell me what every single piece is divisible by. Annika says 2. Annika is right. You could have gone ahead and done a little simplification here and said x to the fourth minus 10x squared plus 14x minus 4 sitting over x plus 2. And we'll work them both out. We should get the same exact thing. Okay? This one would have the coefficients 1, 0, negative 10, 14, and negative 4. And we'll do them both. That way we get the same thing. It's not a deal breaker, but it will make the actual math you do easier to do. I hope you see that. If I go back and follow along the first thought process, negative 2 times 2 is negative 4. I add, I get negative 4. I multiply, I get 8. I add, I get negative 12. I multiply, that's a positive 24. I add and I get what? 52. I multiply and I get negative 104. And I add and I get 112, but it's negative. Now, when I write this out, I would have 2x squared minus 4. Sorry, that's not right. I'd have 2x cubed minus 4x squared minus 12x plus 52 minus 112 over 2x plus 4. Now, IXL would reject that answer. You remember when you looked at the instruction sets, what did it say you're supposed to do with fractions? It said you're supposed to simplify it. So you'd have to simplify that piece, which is not a big deal. Is everything divisible by 2? So negative 56 over x plus 2. Now, we're going to get something that looks a little bit different, and I'll explain why it looks a little bit different. But this one over here we simplified, right? What we did is we pulled a 2 out, and I forgot to show that I actually pulled a 2 out. Pulled out the top and the bottom, right? That's what we did. Let's do our math. We get a negative 2. We drop, or we add, we get a negative 2. Multiply, positive 4. Add, we got a negative 6. Multiply, we got a 12. Add, we got a 26. Multiply, we got a negative 52. Add, and we got a negative 56. You wouldn't look at this thing and realize that what's going on here. The answers look entirely different, don't they? What's this one still have in it? 2's that we pulled. This one doesn't. You kind of have to put it back. You really do, and you'll have to do the distributive property. Some teachers teach to do this in the beginning. When it comes to synthetic division, the honest truth is don't simplify till the end. Or maybe I shouldn't have shown you that you can. It does make the multiplication stuff easier, but you do have to put that 2 back in, which is kind of an issue. But I would do it this way and not worry too much about that. Just make sure you simplify the fraction. And that will get you, I think, all the way through IXL. I don't think the mastery is